Hey everyone! Ever wondered how AI models handle texts that stretch for thousands of pages, like a 10,000-page novel or a sprawling legal contract? It's not as simple as it sounds. Today, we're diving into a groundbreaking technique called TPTT, which is revolutionizing how we train large language models. Let's break it down. Here's the problem. Traditional AI models, like those powering chatbots or translation tools, rely on self-attention mechanisms. Think of it as the model reading every word in a sentence and connecting them all. But here's the catch. This process becomes incredibly slow and memory-intensive when dealing with long texts. It's like trying to juggle 100 balls at once. Your brain gets overwhelmed. Enter TPTT, or transforming pre-trained transformers into titans. This framework is like giving AI models a superpower. They can now handle long texts way more efficiently. How? By combining two smart innovations. 1. Linearized attention. Instead of connecting every word to every other word, which is computationally heavy, TPTT uses a shortcut. It's like using a map instead of memorizing every street in a city. This drastically reduces the math needed, saving time and memory. 2. Memory as gate MMLU. This acts like a traffic controller. It decides when to use the fast, simplified attention and when to switch back to the detailed version. Think of it as a hybrid car, efficiency on the highway, power in the city. But here's the kicker. TPTT doesn't force you to retrain models from scratch. It works with existing models like Llama or Mistral by tweaking just a small part of their brain using LoRA, low-rank adaptation. It's like giving your car a new GPS without replacing the engine. The results? On a test called MMLU, models using TPTT saw a 20% boost in accuracy while running faster. And because it's compatible with Hugging Face, developers can easily plug it into their projects. So why does this matter? Imagine AI that can analyze entire books, legal contracts, or scientific papers without slowing down. TPTT isn't just a tweak. It's a leap forward in making AI both powerful and practical. Let's get technical. Large language models, LLMs, are like superpowered dictionaries that can write essays, code, or even crack jokes. But training them is a massive computational task. That's where techniques like LoRA and MMLU come in. LoRA, or low-rank adaptation, is like giving a model a few strategic tweaks instead of overhauling its entire brain. It's super efficient. Think of it as adding a few sticky notes to a textbook instead of rewriting the whole thing. Then there's memory as gate MMLU, which acts like a smart shortcut. Imagine solving a puzzle and keeping track of the most useful pieces in a mental memory drawer. MMLU does something similar, helping models focus on the most relevant information during training. Together, these methods make training faster and less resource-heavy. Now, let's look at the numbers. In Table 1, we see how different models perform. The Titan's Llama 321B model, for example, has a lower loss, meaning it's more accurate, and processes data faster than its base version. The key takeaway? These optimizations aren't just theoretical, they're delivering real-world gains. But how do these changes affect the model's ability to answer questions? That's where the MMLU benchmark comes in. Think of it as a standardized test for AI. The metrics here, exact match M, partial exact match PEM, and partial quasi exact match PChem, measure how well a model's answers align with the correct ones. In Table 2, the Titan's Llama 321B model shines. It outperforms its base counterpart in strict accuracy, M, and even beats others in partial matches. This isn't just about memorizing answers, it's about understanding context and nuance. The integration of linearized attention, a smarter way to process sequences, and memory mechanisms seems to give these models a leg up on complex tasks. What makes this research stand out? Compared to other cutting-edge methods like Mamba or Liger, TPTT, the framework they're testing, doesn't require full retraining. That's a game changer. Imagine being able to upgrade a car's engine without replacing the entire vehicle. TPTT does something similar for AI models. The implications are huge. For industries with limited computing power, this could mean deploying advanced AI without massive infrastructure. And with LoRa's flexibility, models can adapt to new tasks faster than ever. Of course, there's still work to do. Right now, these tests focused on models with around 1 billion parameters. Scaling up to bigger models might bring new challenges, but the results so far are promising. So what's next? Researchers are exploring even smarter memory systems and testing TPTT on more diverse tasks. The goal? Making AI not just powerful, but practical for everyday use. In short, this work isn't just about faster training. It's about making AI more accessible and adaptable. Whether you're a developer, a student, or just curious about the future of tech, these advancements are shaping the next generation of language models. Thanks for watching. Hit subscribe for more deep dives into AI's coolest innovations. Stay curious, and let's keep exploring the magic of AI together.